Alright, so in this section, we're going to talk about exponential growth and decay. So this still pertains to 3.1. Now we're doing an application of exponential function. So let's talk about the left side. Now the left side is called exponential growth or decay. So you have a formula, n equals initial m. So when you see n subscript 0, it means initial, times 1 plus r to the power of t. Now r is the rate and t is time. Now the one I wrote below is using the letter a instead of n. Now the reason I wrote that is because that formula is generally used by other math classes like calculus or engineering math. So again, if you see a equals a sub 0 times 1 plus r to the power of t, is basically the same as the one we're talking about here. Just get used to it, just different letters. Same formula, just different letters. Now, here are the descriptions. So if r is growth rate, then r would be greater than 0. If r is decay rate, then r is less than 0. So what it means is that sometimes problems will either say growth rate or decay rate, or sometimes they would give you the r first. So if r is positive, it's going to be a growth rate. If r is negative, less than 0, then it's going to be a decay rate. So sometimes some problems will give you the r value, or sometimes they will tell you it's a growth rate or a decay rate. Now, generally, this formula is used when it's talking about to find the rate or to find the growth or decay at a certain amount of time. Like what is the amount within a month, within some years, like 5 years, 10 years, semi-annually or annually. So if you see that keywords in a word problem, you will use this formula. Now, continuous exponential growth or decay, the formula is n equals initial n, where it says right here n subscript 0, that's initial n, times the e function to the power of k times t. So again, it's n equal initial n times the e function to the power of k times t, or kt. Now again, here the e function is the exponential function. It's the same function used in algebra 2. So if you're using a calculator and it says e, you don't just type in the letter e, you actually have to input the e function. So be careful when using a calculator. Don't mix it up with the letter E, like the keyboard E. There's a different function using that letter E, which is the E function, or exponential function. Now, again, the reason I'm using the letter A instead of N is because some other math classes would use this function with the letter A. So again, it's the same process, same function, just different letters. Now, the description. If k is continuous growth rate, then k is greater than 0. If k is continuous decay rate, then k is less than 0. So just like over here, you would determine if it's a growth rate or decay rate if they give it to you. Now, if they give you k that is a positive number, it's a growth rate. If they give you a k less than 0, meaning like a negative rate, then it would be a decay rate. So again, sometimes some problems will tell you it's a growth rate or decay rate. Sometimes it gives you the k value, and depending on if it's positive or negative, that's when you determine if it's a growth or decay. Now, to determine to use this formula is the key word continuous. So if a problem tells you find the amount after a continuous rate, then you would use this formula. Now, if it doesn't tell you what it is, like if it doesn't say after a certain amount of months, hours, years, or semi-annually or annually, then most likely you will use continuous exponential growth or decay. But sometimes the best way is some problems would say continuous, and then you would use this. But if it doesn't tell you a set amount of time, you would use continuous. So for example 1, and this one actually has parts to it, so we're going to do it step by step. So in example 1, the problem is, it says South America has the population of approximately 110 million people. If South America's population continues to grow at the described rate, predict the population in 10 and 20 years at the rate of 1.42% annually and 1.42% continuously. So this actually has two parts, annually and continuously. That means we're going to use the exponential growth decay formula and the continuous exponential growth or decay formula. So two formulas. First, we're going to focus on the annually part right here. So the formula for it was n equal n initially or sub-zero times 1 plus r to the power of t. So right now we're just going to focus on setting up the formulas. So basically it's just asking predict the population. So you're looking for n. When it says predict the population, you're looking for n. Again, sometimes it's a sub-zero 1 plus r to the power of t. So again, predict the population, you're just looking for a. Now, n sub-zero is the amount of population that was given at the beginning of the problem. So 110 million people. So what you're going to do is just fill in a sub-zero. Now we don't know what n is, so we're just going to keep it as n. So 110 million people. Alright. Now, I put in the 1 because that's the one right here. Now you put in the r, the rate. So here, it's 1.42%. Now this is the part where we have to be very careful. If it's percent, we have to convert into a decimal. So 1.42%. To convert into a decimal, all we have to do is move the decimal places 2 times. So 0.0142. Again, all I did was move the decimal places behind the 1 to the left. So if it was right here initially, so 1, 2. So again, all I did was move the decimal to the left 2 places. 1, 2. So that's the rate I'm going to put in here. To the power of t. Now, I'm going to simplify it, combine these two. So again, it would be n equal 110 million times, and then again, we can combine this. Now, this is a whole number. So this whole number is added with this 0 whole number right here. Not these two. These are after the decimal. So when it's 1 plus 0.0142, it simply becomes 1.0142 to the power of t. Again, I only added the 1 to this 0 whole number. So any number before the decimal is the whole numbers. Alright. It asks you, predict the population when it's at 10 and 20 years. So when t, that's time, is 10 years, so our formula is n equals 110 million times 1.0142 to the 10th power. So that's all you have to do. Now, if I were to do the time for 20 years, so what I'm going to do is I'm going to write t equals 20 years. So again, the formula would be n equals 110 million times 1.0142 to the power of 20, or the 20th power. So that's what you would put as your formula. So again, the key work is you set up the formula correctly. So for 10 years, or t equals 10, this is the formula you would write down, or set up actually. When t is 20 years, this is the formula you would use. Then you would type that into the calculator and then input it. But right now we're going to just focus on setting up the formula. Once the setup is good, then just typing it into the calculator is just easy work right there. The most important work is trying to get the information from the word problems. So the population, the amount of population, the rate, and the time. 10 years, 20 years. So again, the most important work is the setup. If you cannot get the setup correctly, then using a calculator is no point. So again, you must get the setup correctly in order to get the answer correctly from the calculator. Again, the calculator work is easy. Most important is just the setup. Alright, again, we're still using the same problem as before, but now we're going to talk about 1.42% continuously. And just like before, when we're doing with formulas, it's always best to use it in decimals if given in percent. So if it's 1.42%, then the decimal value is 0.0142. Again, all I did was move the decimal places twice, 1, 2, to the left. Now, continuously, that means we have to use the continuous exponential growth or decay formula. So it's n equal n sub 0, or initial n, times the e function to the power of kt. So again, this is the rate, and we have the k value, and then we also have the years, 10 and 20, that's the t value, and then we have the sub 0, or n sub 0, or initial n, 110 million people. Now all we have to do is just set it up. Alright, again, just like other math classes, they might use the letter A, so it's no difference in the process, just different notation, different use of letters. Now, so what I'm going to do is going to plug in k value and the initial n value, or n sub 0. So again, same problem, predict the population. So you're looking for n. So our n sub 0 is the amount that was given, so 110 million times the e function to the power of, now again, we're using this decimal value when given rate, can't use percent, we're going to use decimal. So 0.0142 to the t power. Now the reason I use t because I don't want to put in time yet. I'm just plugging in n sub 0 and k. Now again, the problem was predict the population, you're looking for n. So it gives you the time. So t is 10 years. So all we have to do is just set it up. So 110 million, that was the initial amount given, times the e function to the power of 0.0142 times 10. So that's all we have to do for that setup. Now, it also asks you for 20 years. So when t is 20 years, It's basically the same setup but different time. So again, 110 million times the e function to the power of 0.0142 times 20. Now again, keep in mind that when you're using the e function, it will ask you what's the exponent. So on a calculator, when you select the e function, it will ask you to type in the exponent. So you make sure when you type it in, you close with parentheses, because you don't want to mess up on your work after you did all the setup, and then you might get the wrong answer. So the two formulas that I underlined are the formulas you would use if it was t equals 10 years or t equals 20 years. So you would type these in, and then whatever comes out, that's your answer. But again, most importantly is the setup. If you cannot set up correctly, then what you get from the calculator maybe be the incorrect answer. So again, this is to work for continuous exponential or growth or decay. So you will use this formula and set it up correctly in order to do well or get the correct answer from the calculator. But right now, main focus is the setup.